Okay guys, today we're going to do limited reagents. If you don't like the word reagent, you can use the word reactant. Remember, a reactant is something that reacts in the with each other to make a product, and reactants are always on the left-hand side of the yield sign, so we're talking about limited reactant or reagent. That means one of them is going to get used up. The way you're going to know you're dealing with a limited reagent or reactant problem is when you read the information, you have two givens, and not only are you have two givens, those givens are always going to be reactants, meaning on the left-hand side of the equation. So in class, we made a little change in our problem. On A, we changed the number. It says how much sulfuric acid can be formed. On your sheet it said 320 grams. We changed that to 64 because I didn't want you to always think that the bigger number is always going to be the thing you have excess. So we just went ahead and made the numbers the same. So you have 64 grams of sulfur dioxide and you have 64 grams of oxygen. And so you have two given informations, and so I would like you to write your givens. You have two givens that you have 64 grams of sulfur dioxide and you've got 64, notice you've got two givens, 64 grams of oxygen. And the way you're going to know this is limited reagent is because both of those givens in our balanced equation that we're looking at are both over here on the left-hand side. So what that means is you're going to run out of one of them. And the example I gave in pre-AP is if you had that peanut butter and jelly sandwich that you want to make, and you got a whole jar of peanut butter and a whole jar of jelly. If you only have two slices of bread, you're only going to be able to make one peanut butter and jelly sandwich because you're just not going to have enough of one of your ingredients. And so we've got to figure out which one of these we don't have enough of, and that's why I made them the same number. Made them the same number for you. Couldn't just look at them and tell, and you can't just look at them and tell because even if one's the bigger number, it's not necessarily going to be the limited reagent. We did that cookie lab in pre-AP, remember, and the salt was the smallest number, but it sure wasn't our limited reagent. Alright, what we're looking for in this one is we're looking for how much sulfuric acid. So we've got two givens, you've got one wanted, and you're wanting to know how much sulfuric acid you can make. So when you encounter a problem like this, two givens, both of them being a reactant, and one wanted, you're going to have to do two stoichiometry problems. So you'll start with your givens. We're going to start with sulfur dioxide, and we're going to take him all the way, mass, and take him to sulfuric acid. Again, this unit's going to come down, and we're always going to go to the mole first, and it's always going to be 1 when it's with grams. If it's mole over gram, it's always going to be a 1 with that word mole, and this is going to come from the periodic table, 1 sulfur and 2 oxygens, which actually weighs 64.1. That will cancel out the sulfur dioxide grams, but now you've got moles, so now you want to switch. And the way you switch is with what's called the mole over the mole ratio. Mole of SO2 on bottom, mole of, what are we looking for? We're looking for H2SO4, sulfuric acid. And here, where are we going to find the numbers? It's mole over mole. We've got different substances on top and bottom. You're going to find these in our balanced equation. Up here we've got a 2 in front of the sulfur dioxide, so we're going to put a 2. Here we've got a 2 in front of the sulfuric acid, so we're going to have a 2 there. If I stop right there, I'm going to have the moles of sulfuric acid, but I'm going to take them all the way to grams. So we're going to bring mole down, and you're going to the grams of sulfuric acid. And this is not mole over mole, so with this mole will be a 1. Anytime I'm pulling from the periodic table, it's always 1 with the word mole. I've got 2 hydrogens, 1 sulfur, and 4 oxygens. I'm going to add up off the periodic table, and that adds up to 98.12 grams. And I'm going to then just crunch my numbers, do the math. And when I do this math for this problem, I'll find that I can make 98 grams of sulfuric acid. Now, I'm not done because I don't know if I really can make the 98 grams. So I've got to do a second stoichiometry problem, starting with my second given information. So I'm going to have this many grams of oxygen. I'm going to repeat this. And so this time I'm going to bring grams of oxygen down. go to 1 mole of oxygen. Oxygen 16 plus 16 is 32. This is going to cancel out. I'm ready now for the mole of H2SO4 on top. It is a 2 in my balanced equation. I'm going to have the mole of O2 on bottom. If I look at my balanced equation, which I've got hidden up there, but you should have it on your sheet, it is a 1. This will cancel with this. I'm going to continue. 1 always goes with this mole, H2SO4. And then we're going to find out how many grams that would be of H2SO4. Add this up off the periodic table, which we already added it up there, so we should be able to just pull that number right on down. And then if I do this, so I'm saying if I have 64 grams of sulfur dioxide, it's going to make 98 grams of sulfuric acid. If I have 64 grams of oxygen, let's see how much that's going to make. We multiply and we divide. It's going to make 392.48. If you want to get technical for sig digs, we'll do 392 grams of H2SO4. Then you're going to have to ask yourself, can I really make 392? And the reason you can't make 392 is once you've made 98 grams, your sulfur dioxide is all gone. So this cannot happen. And in pre-AP, I made you put a big X through it for you wouldn't be tempted to use it. This is how much I can make. This is going to be my answer to letter A. My answer to letter A was how much sulfuric dioxide can I make? Sulfuric acid can I make? And you can make 98 grams. You'll never be able to make 392. So to answer B, B says what is the limited reactant? And your limited reactant is going to be one of these two givens. One of these two givens is the one you're going to run out of first, and the one you're going to run out of first is the guy that made the least amount. So this guy right here, 64 grams of sulfur dioxide, is your limited reactant. This is your answer to letter B. And in pre-AP, I had you label it as the LR. This is the limited reactant, the one you're going to run out of first. I had then you label this one as your ER. And the reason this is your ER is because that's going to be your excess reactant, meaning you're going to have some extra of him left over. We can go ahead and answer this right here is 98.0. We answered that a while ago. So I've got my LR figured out. I've got my ER. The next question, which is letter C, is how much of your excess are you going to have left over? We know that we're not going to use all 64 because if we were using all 64, it would not be an excess reactant. So in order to do this one, I had a weird saying in pre-AP. I said you're going to start with the LR and you're going to go to the ER. And then some of you made up a weird thing about somebody getting shot or stabbed in the living room and going to the emergency room. Basically, you're going to start with the LR and you're going to go to the ER. This is to figure out your excess. So you're going to start out with 64 grams of sulfur dioxide. You're going to first convert it to the mole. And then you're ready for the mole. This guy's mole's on bottom, the one that you're trying to get rid of. And up in the balanced equation, there's a 2 in front of him. This time, instead of H2SO4, you're going to put O2. We're going to the ER reactant. And in front of that is a 1. We're going to take that all the way 2 grams. That's going to be a 1. If you'll cancel units out, you can see everything's canceling nice and easily with one another. Going to multiply and divide, and what you come out with is 15.97, which we could just easily round to 16.0 grams of oxygen. What does this mean? Well, 16 grams, this is what you will use. You will use 16 grams of oxygen. That's not how much you're going to have left, though. If you're going to use 16 grams of it, we want to know, well, how much are you not going to use? Well, you go back and you say, well, I had 64 grams of oxygen. This is how much I have of it. Remember, that was given to us. I am going to use 16 grams of it. It's kind of like money. You have $64, you're going to use 16. How much will you have left over? You're going to have 48 grams of oxygen left over. Left over, remaining, extra, however you want to call it there, that's going to be extra stuff that you're going to have left over for this reaction. And that's how much excess you'll have. Excess means extra. The last part of your notes was percent yield. For percent yield, it is always actual, what you get in lab, and this is going to be given to you in the problem, over what you really should have gotten, which we say theoretical, which is stoichiometry. Stoichiometry tells you, in theory, we call this the theoretical, what you should have gotten, and then you times it times 100. And the example, I couldn't remember the exact example that Ms. Bowles had given you guys, so I would just say, well, if in lab you made, this would have to be given to you, or you would actually do a lab and measure, if you made 95 grams of sulfuric acid. And I would ask, what is your percent yield? You actually did a pretty good percent yield in this problem because, well, 95 grams is what you really made in class. It's given to you in that problem. According to all that stoichiometry stuff, notice this is not sulfuric acid, this is oxygen, so I'm not going to play with any of those numbers. This is oxygen, not playing with that number. Look right here. I really made 98 grams of the sulfuric acid, not 392. Remember, you put an X through that. I really made 98 grams, or you should have made 98 grams. Sorry, you should have made 98 grams according to stoichiometry. You made 95, so the 98's going on bottom here. This is stoichiometry. You would have done a stoichiometry problem for that. And you multiply it by 100. You actually did pretty well here. If you take 95 divided by that, you get that you were 96.9% with your yield there. So that's actually a very good yield. Most companies around 80%. I think that's working pretty well. So this